Hello friends, welcome to Risingpearl.com. Today we are talking about a brand new series which we have just started called Arithmetic Progressions. Friends, this is webisode number 2. I hope you're following us along at Risingpearl.com. In the last webisode we looked at what is an arithmetic progression, and here we are going to find out in this webisode some important abbreviations about arithmetic progressions and what is a general form of writing any arithmetic progression. So friends, let's get into it. Now, in the last episode we looked at we randomly picked up 5 sets of numbers. So we looked at this as an example, this collection, or this series, and these series. We looked at in the last episode at risingpearl.com each one of these series, and what we noticed was that in each of these cases, they are all examples of arithmetic progression, or in short AP. So what is an arithmetic progression and what is that we have learned? We learned that each of these numbers within a series is called a term. We use the word term to refer to each one of the numbers inside of a series or inside of an arithmetic progression. So for example, this is a term, and which term is this? 1, 2, 3. This is the 4th term. So this particular one is the 4th term. Similarly, if I look at this one, in this series, this is the 1, 2, 3, 4, 5th. So this number 90 is the 5th term in this series. Similarly, this is the 2nd term in this series, and this would be the, let's take a look, 1st, 2nd, 3rd, 4th term. So we looked at each number within a list or a series is called a term. Then we saw what is an arithmetic progression really. So we saw in the last webisode that arithmetic progression is defined as a list of numbers, a collection of numbers, or a series of numbers in which each term, that is each number, is obtained by adding a fixed number to the last preceding term, right, except the first term. So in other words, there is a fixed number. So for example, if we take this particular series, this collection, and if we take a look at this term, this is the 2nd term. So if this is an arithmetic progression, that means if we add a certain number to the 2nd term, we will get the 3rd term. And what is that number? We looked at that in the last webisode. That number for this example is 20. So if we add 20 to the 2nd term, we get 50. Similarly, if we start at 50, which is a 3rd term, and we add 20 to it, we get the 4th term, so on and so forth. Or in other words, if we take a look at any of the term and subtract the previous term, right? So if we start at the 3rd term and we subtract the 2nd term from it, we will see that there is the difference, whatever the difference is, that difference is common for each of these cases. That means if you start with the 4th term and if you subtract 3rd term, you will get a difference. If you take the 3rd term and if you subtract the 2nd term from it, you will get a difference, and that difference will continue to be the same, right? And that is what we looked at. That difference is known as common difference. So the fixed number is the common difference. So these are things we looked at in the last webisode, which was the first webisode. Now let's do one thing. Let's take a look at the first example one more time. And we talked about this as an arithmetic progression, right? So now in an arithmetic progression, what we have seen is that this is the first term. We represent the first term by the letter A. It is just a convention. Yes, it is not B, it is not C, it is not X. It is none of this. So it is convention, standard practice it is none of these. It is standard practice to represent the first term of arithmetic progression by A. So we say A is equal to 8. And then every subsequent term, so this is the 2nd term, this is the 3rd term, this is the 4th term. So instead of saying, let's say for the 2nd term, instead of writing it as 2nd term equals to 11, which is absolutely correct. But what we will do is we will write this as A, and we will write 2 under below A, like a subscript. Now remember that if you have, let's say for example, 3 to the power 2, this will be 9, but this 2 is raised right above 3. So this is called a superscript, but we will represent each term in a subscript form. So second element will be written as A subscript 2. Similarly, for example, if I want to represent this term, so I want to write this in a short form as, this is which term is this? So 1, 2, 3, 4, 5th. So I will say the 5th term, or A subscript 5, is equal to 20. So in this particular webisode, I am going to talk about some of these abbreviations that we would like to use, or we often use when we are actually looking at or handling arithmetic progression. So similarly, very quickly in this example, so A, we don't normally write like A1, instead we just write A. So A will be equal to 8. So similarly, A2 will be equal to 11. Let's quickly write this. A3, which is the third term, first, second, third, that will be 14. Similarly, A4, let's write it here, A4 will be equal to 1, 2, 3, fourth term, which is 17. Fifth term is 20, and sixth and final term is 23. So A6 is 23. So this is important, friends, just to keep in mind how we write in a short form the first term, which we always represent as A, and each subsequent term we write as subscript. So A2 represents second term, A3 represents third term, A4 represents fourth term, A5 is the fifth term, and A6 is the sixth term. Now, so let's take a look. Now, here we talked about, so the first term we will write this as A equal to 8, right? Now, we just now saw that A2 is 11, A3 is 14. And for right now, I want to pause here. Now, let's do one thing. Now, what is the common difference? We talked about common difference, and we don't write CD for common difference. Instead, we write common difference by only D. We don't write it CD. Common difference, we write it as D. This is again a common practice. So whenever you have an arithmetic progression question, we will refer the first term as A, lowercase a. We will represent common difference as lowercase d. And we will represent every subsequent element, or term I should say, as A, subscript the actual number of the term. So now, as we saw earlier, right, we notice that if we take any term, so let's say we take this term. This is the first, second, third, fourth term. So common difference is nothing but A4, that is the fourth term, minus A3, that is the third term. That is, if we take any term and subtract the last term from it, that gives us the common difference. So D is equal to A4 minus A3, which should be same as if we take the third term and subtract the second term from it. Or similarly, if we take the second term and subtract the first term from it. It is very important to get this idea that exactly what is going on. So the common difference again is nothing but you take a look at any term except the first term, because we want to start from the second term, because the reason is we are subtracting the last term from it. So if we start here, there is no other term to subtract. So first term is represented by lowercase letter a. Common difference is represented by lowercase letter d. Let's take a look at maybe one other example. So in this case, what we have, this is the second set of numbers. So this again, if this is a arithmetic progression which is given to us, The first term will be represented by lowercase a, and that is 10. And common difference will be represented by lowercase d. And how do we find out the value of common difference? We simply take any of the term. It does not matter. From second onward, let's say we take this term. We take this term, which is 1, 2, 3, 4, 5. So this is a5 minus a4. So if we do that, a5 is minus 10 minus a4 is minus 5. So we will get minus 10 plus 5, or in other words, this will be minus 5. So common difference for this arithmetic progression represented by lowercase d is minus 5. So friends, also just wanted to highlight one other quick thing, which is that if you look at any term, right? So let's say this term, third term. So third term minus second term is equal to common difference. So if you take this on the other side of the equation, so you will have third term as second term plus common difference. That means that if you take the second term and if you add common difference to it, you will get the third term. Similarly, this is, so I just wanted to make sure that you understand this, because I don't want you to be confused. If you were to go back and take a look at the way we have defined arithmetic progression, is that each term is obtained by adding. This is what is meant by adding. So if you take like the third term and if you add the common difference, you get the fourth term, right? So in other words, because common difference is nothing but if you take this on the other side, it will be a4 minus a3. So it is the same thing. So if you take any of the terms and if you add the common difference to it, you get the next term. So now friends, now that we have understood, so basically first term is always represented by lowercase letter a, the common difference is always represented by lowercase letter d, and subsequent terms are represented by a with a subscript that indicates the number of the term, right? The term number. Now it's important to note that any arithmetic progression, it can have finite number of terms. So all the examples that we have looked at, they have finite number of terms, right? They were like 5 terms or 6 terms or 6 or 7 terms or 4 terms in it. Now there may be arithmetic progressions, there are actually arithmetic progressions where you have infinite number of terms. So fixed number of terms, let's take an example. So 10, 5, 0, minus 5. This is an example of an arithmetic progression where we have finite number of terms. What is the meaning of the word finite? Finite means it's a fixed number. You can count this number, right? So in this case, for example, this arithmetic progression, we represented arithmetic progression by AP in abbreviated form. So AP equals 10, 5, 0, minus 5. This arithmetic progression has 1, 2, 3, 4 terms. So it has finite number of terms, right? What is an example of an infinite number of terms arithmetic progression? So how about a set of all natural numbers? So if I say a set of all natural numbers, now you know the natural number set, it starts from 1, 2, 3, 4, 5 and it goes till plus infinity. The reason this is a arithmetic progression is because if you take a look at any term and if you add 1 to it, you get the next term. Similarly, if I take a look at this term and if I add 1 to it, I get the next term. So this is an arithmetic progression, but the number of terms in this is infinity. So we call this as infinite arithmetic progression. So if you have infinite number of terms, as in this example, this will be called as infinite arithmetic progression. If we have finite number of terms in an arithmetic progression, we will call that as finite arithmetic progression. Now one other thing that I want to mention before we wrap up this is that we talked about the first term is represented by A. The second term is represented by A plus D. Because remember, we talked about the second term is obtained by adding common difference to the first term. So the first term is A, and if common difference is D, then I can add D to A. That will give me the second term. Similarly, my third term will be obtained by taking a look at the second term and add D to it. So which will be, my second term is A2, but A2 is A plus D. So it will be A plus D, and this is my second term, and I'm going to add D to it. So this gives me A plus 2D. So similarly, if I look at my fourth term, I will get that by adding D to the third term. So because I'm looking at my fourth term, I take my third term and add D, which is the common difference to it. What is my third term? Third term is this. So I take a look at my third term, A plus 2D. This is my third term, plus I add D. So 2D plus 1D will be 3D. So A plus 3D. So as you can see, the first term is A. First term is A. The second term is A plus D. The third term is A plus 2D. A plus 2D. Fourth term is A plus 3D. A plus 3D. And it goes so on and so forth. So this way of expressing an arithmetic progression in terms of the first term and common difference. So first term A, second term A plus D, third term A plus 2D, fourth term A plus 3D, so on and so forth. This form of expressing an arithmetic progression is often known as the general form of writing any arithmetic progression.